Dear students, in this lecture we will discuss few numericals related to inclined plane surface immersed in a static fluid. So here we have a triangular plate which is immersed in water in such a way that plane of the plate makes an angle of 60 degree with the free surface. And the plate is of 2 meter base and 3 meter altitude. And the base of the plate is parallel to the water surface and at a depth of 2.5 meters from the water surface. Here we need to determine the total pressure F and the position of center of pressure H star. So now we'll try to draw the figure. So here this horizontal line represents the free water surface. This inclined line is indicated by the side view of the triangular plate. And the length of the line will be equal to altitude of the triangular plate, which is 3 meters. And this inclined plate, it makes an angle of 60 degree with the free water surface. Base of the plate is 2 meters. And it is said that base of the plate is parallel to the free water surface and at a depth of 2.5 meters. Now we'll try to mark the centroid and position of center of pressure. Now this distance will be H bar. This distance will be H star. You know that total pressure F is given by rho G A H bar. So here rho is equal to 1000 kilogram per meter cube. Capital A represents area of the triangular plate, which is equal to half into base into altitude. We will get it as 3 meters square. Now we will give notations to certain points over here. Let this be A, B, C and O. We know that in triangle BOC, sin 60 is equal to 2.5 divided by OC. From this, OC is equal to 2.5 divided by sin 60, which is equal to 2.88 meters. Now, GC. GC is the distance from the base of the triangle up to the centroid. This distance is GC. We know that GC is H by 3, which is equal to 3 by 3, that is equal to 1 meters. Now we can write OG is equal to OC plus GC and we will get it as 3.88 meters. Now in triangle AGO, sin 60 is equal to H bar divided by OG. From this, H bar is equal to OG sin 60, which is equal to 3.88 sin. We will get it as 3.366 meters. Now we will substitute in our expression F is equal to 1000 into 9.81 into 3 into 3.366 and we will get it as 99061.38 Newton. Next we will calculate the position of center of pressure H star, which is equal to Ig sin square theta divided by AH bar plus H bar. So here Ig is the moment of inertia of the triangle about the centroidal axis and this axis should be parallel to OO axis. Ig is given by 1 by 36 BHQ, which is equal to, we will get it as 1.5 meter raised to 4. Now we will substitute in our expression H star is equal to, we will get it as 3.477 meters. We will solve one more numerical. Here we have an annular plate of 3 meter external diameter and 1.5 meter internal diameter, which is immersed in water with its greatest and least depth below the water surface as 3.6 and 1.2 meter respectively. Here we need to determine the total pressure and the position of center of pressure. So we'll try to draw the figure. This horizontal line represents the free water surface. Since it is an annular plate, we have two diameters. The outer diameter is 3 meters. The inner diameter is 1.5 meters. Here the central portion of the plate is hollow. Now we will mark the centroid of the plate and the position of center of pressure. This vertical distance is h bar. Least depth is at a distance of 1.2 meter from the free water surface and greatest depth is at a distance of 3.6 meter from the free water surface. This angle is given by theta. So here we know that total pressure is equal to rho GA h bar. Rho is equal to 1000 kilogram per meter cube. Area capital A is equal to pi by 4 into outer diameter square minus inner diameter square. So here it will be pi by 4 into 3 square minus 1.5 square. We'll get it as 5.31 meter square. Now we need to calculate h bar. So here we'll mark certain points. Let this be A, B, C and O. We know that sin theta is equal to 1.2 divided by OC. And again sin theta we can write it as 3.6 divided by OC plus 3. Where 3 is length of this inclined side, which is equal to outer diameter. We can equate these two equations. By solving, we will get OC is equal to 1.5 meters. Now, sin theta will be 1.2 divided by 1.5. We will get it as 0.8. Now, in triangle AOG, sin theta is equal to 0.8 is equal to h bar divided by OG. Now this OG is equal to GC, which is 1.5 plus OC, which is also 1.5. By solving, we will get h bar is equal to 2.4 meters. Now we will substitute in our expression F is equal to rho G A h bar. We will get it as 125019 Newton. And now h star is equal to Ig sin square theta divided by AH bar plus h bar, where Ig is moment of inertia about the centroidal axis, and this axis should be parallel to our OO axis. And this Ig for a hollow circular plate is given as pi by 64 capital D raised to 4 minus small d raised to 4, which is equal to pi by 64 into 3 raised to 4 minus 1.5 raised to 4. And we'll get it as 3.727 meter raised to 4. And we can substitute in our equation h star is equal to, and finally we'll get it as 2.587 meters.